Get a demo that will work just fine.
Yeah, of course.
And what you just see on the screen is like giving away the whole pine, so ignore it. Go ahead, Ray.
Yeah, so my name is Ray. I'm a developer advocate for the Google Cloud Platform. If you have any questions, you can reach out to me on Twitter @Saturnism. And I'm very happy to be joining with.
So before that, Ray is awesome. It's not on his slide, but I can tell you that.
Oh, thanks.
It's right there, white on white. And he's awesome. And well, yeah, I hope you know me by now, because I really tried to for those 2 days. My name is Baruch. I'm developer advocate with JFrog. Also, it's me to blame for the bad parts of the content of those 2 days. Whatever was good is thanks to our great speakers. Whatever was bad is my fault. And let's see how that goes.
Yeah, let's see how this goes.
@jbaruch on Twitter, so feel free to connect with me there as well.
Yeah.
OK, and Igor is here. Now we can start. Now it's all good.
Now we're good. All right, so to prepare for this talk, I actually created an application that is created with microservices with Spring Boot behind the scenes. It's a Java application. And it's a pretty simple, straightforward guestbook application. I used this application quite a few times already. But just to give you a high-level example of what it actually does, give it a name, give it a message. We will store the data into MySQL, and we will say hi to you. Right? This is a very, very simple app. But
so but just go. I just try to understand something.
Yeah.
So this stupid screen is powered by 3 different microservices.
Yes, yeah, but this,
okay. No,
this is the best I can do. I'm not a front-end developer. Like, this is the best thing I can do to make it look.
So basically, every word here comes from a different microservice.
Pretty much so, yeah. Even your name and message. No, just kidding now. That's really putting into the template.
OK.
Yeah. But behind the scenes, we do have a couple of microservices here. We got the front end and 2 back-end services. And we got MySQL and Redis. And all of these things are containerized. They are actually deployed in Kubernetes.
Not over-engineered at all. No.
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 But it demonstrates the great point. If you're running a microservices application, right, no matter how simple the application may be, if you do break it down, if you do it correctly, right, you will end up with multiple instances of the apps that you have to manage and deploy. And also, if something goes wrong, right, you have to go figure out where exactly this goes wrong. And I think this is where Kubernetes really shines. OK? So let's see how this thing.
Yeah, so let's do demo.
Yeah, so I want to show you. So I have already deployed everything into Kubernetes. And the way I have done it is by using a YAML files. So this is great, because I can check in what my deployment should look like. And all I need to do to deploy is by doing kubectl apply dot. And it's going to deploy all of these YAML files. And I'm going to spin up all of my instances. So I got multiple services running right now. I have the guestbook service, the hello world service, everything for this trivial example. However, we also exposed the front end via an external load balancer. And all of these things are just things you get out of the box with Kubernetes. So I'm going to find this front end with the UI. I'm going to go see what that looks like. OK, so hopefully you'll see. Ooh. Huh.
What's that?
I don't know.
OK, so let me just state for the protocol. After sawing your architecture, I would be really surprised if it actually worked.
Thanks. Well, but the deployment was really easy. I deployed this yesterday. It was working just fine.
OK, so I know exactly what you do. We are all both seasoned speakers. And that's where you start the video with the pre-recording demo.
The what?
You have the backup video with the pre-recorded demo that works.
I thought you were creating a video. I was playing pool last night. I was playing pool the whole evening. OK. Yeah, but I thought, no, you don't have that?
So it's either we're going to fix this demo, or our talk here is over.
I think let's call it early. Let's go have some.
Let's go home?
No, I'm just kidding.
No, OK, let's fix it then. But at least you do have staging, don't you?
I do have staging, yes. Yes.
Okay, so let's try staging.
So let me see here. So in Kubernetes, in this cluster of 5 machines that I got a very small cluster, I actually carve it up into different namespaces. So I can deploy exactly the same application into the same cluster, but in a different namespace. So I can say get pods. I'm going to say, what instances am I running in my staging environment? Yeah, it's running here.
Now I want to do a quiz here.
OK.
Now, who thinks that it works on staging? Look at the.
Oh, come on.
What of confidence?
What of confidence? Everything works. I know you're all here just to see like a live coding example, like a live demo, and you're just waiting for things to fail. Well, today's your day, isn't it? But let's see if staging. All right, let me see here. So staging, no, that's not bad.
So staging works.
Well, of course it works. How many people actually deploy something into production knowing it didn't work in staging?
All the speakers in the room, that's for sure.
Oh, well, there you go.
I told you, all the speakers in the room.
Well, of course it works in staging. I mean, you wouldn't have promoted it unless if it works in staging. But you do get these issues in production all the time.
Wait a second. Isn't like the whole containers, Docker, Kubernetes thing about we want that one happen again? Whatever we build once, if it works in every environment?
Yeah, I mean, it should. I mean, it's the same exact images. It's the same exact deployment file. In fact, I deploy the staging environment exactly the way I deploy production, which is by using the same command line. I can say apply -dot, and I say go deploy into staging. It's exactly the same thing. But sometimes things just happen in production. I don't know. No matter what you do, there's always some user errors. Or whatever.
Okay.
Yeah.
So let's debug it. And I think we should start with the origin and look at the images.
Okay.
Which image did you deploy?
So that is an easy question to ask because I'm checking all the YAML files. I can actually open up one of them because that's what I deployed.
VIR, do you know how to exit it before you enter it?
Yeah. Let me see. You mean Vi?
Yeah.
I kind of know. I'm a Vi user myself. I'm pretty seasoned.
Okay. Just checking. Million questions on Stack Overflow.
I heard about that, yeah. Oh, I have seen a lot of these. So let's see here. So I got this YAML file here that describes what I'm going to deploy, what I have actually deployed. And I can see that I'm using the container image here that's coming from Artifactory, and it's called Hello World UI. Colon latest.
Latest.
Yeah.
Okay, latest.
Latest tag, yeah, of course. We're going to, what? This is
latest.
This continuous delivery, right? We always deliver the latest to production, no?
Okay, now I have one question. Now, in Artifactory, you have your Artifactory up and running?
I think so, yeah.
Yeah, so let me just ask you another question.
Okay.
So here, that's our Artifactory, and let's zoom a little bit to it. Wait
okay.
a minute.
Yeah. You show me Artifactory.
Yeah, so let's zoom in a little bit.
Yeah.
So this is our Docker repository. It actually comes from here.
Okay.
And this is our, we're looking at the UI, right?
Yeah.
So here are all the images that we have here.
Huh.
And we have a latest. Do you know which of those is actually latest?
I don't know. What could it be? Because, no, you're right. Because if you're running latest, if you run latest against your machine, unless you repull the latest, you could be running the wrong versions. I have no idea what this could be.
OK. So anyone knows what identifies a Docker image like completely without names? 42? That's a good hint. It is some kind of a number.
No, I see 27 to 50. I don't see 42 here.
Hash, here we go. It's good that we have Carlo here. Nice. Someone knows Docker in this room. Can we get the hash, the SHA-256?
Yeah, actually, if you're running Docker locally, you can do Docker inspect, right?
Right.
When I'm running this on the Kubernetes server, what I can do is I can find all of the running instances, and I can say kubectl describe, and I'm going to put in one of these UI front-end instance. And from here, describe pod, sorry. There you go, describe the pod. If I scroll up a little bit, I should be able to see that I got one container running in this one instance of the application. And I have the image name, which is latest, because we're doing continuous delivery here. But then we have the image name, image ID.
So we are in the lock. Let's take the SHA-256 and actually search Artifactory with it.
OK, how do I do that?
Here, that's the search.
Yeah, there we go. Yeah.
And we have a checksum search.
OK, so I'm going to paste it
and right. And we will see 2 items. Now, 2 items means that we have 2 different tags for the same image.
Okay.
One of them is obviously latest.
Yeah.
But we also see the original image that was retagged as latest.
I see.
And that's 50, not 42. Surprise. Now, the good news are now we can know more about it. So let's go to this artifact and take a look. Maybe we can learn something from there and understand why it fails.
So let me see showing tree. Is that right? So
yeah. Okay. So here we go.
Yeah.
We have more information here.
Okay.
Right. We see the general information of who submitted it. It was Mark Galpin for some weird reason.
Mark?
I have no idea.
You're not Mark. I'm not Mark.
Yeah. So no. Thankfully, I do know, and that's the time to thank Mark Galpin for helping us with this demo while I'm running around through the rooms here, trying to troubleshoot faulty HDMI connectors.
So Mark committed the bad code. I'm just kidding. No. Yeah.
It's his fault.
No.
Okay.
All right.
How about Docker info? Maybe there is interesting information there.
Yeah.
You know what? I have a better solution. Mark, do you know what doesn't work? Mark doesn't know, so we have to dig.
Fine. Let's figure this out. Okay.
Okay. What do we see here? Any useful information in the layers?
Well, at least we know where we're copying the jar file.
Oh, jar file. So you have a Java code running inside this Docker image.
Yeah, it's a Java application.
Good. Okay. Can you see which file you copied as app.jar?
This is a very, very long name. I don't know what this is.
Oh, is there a way to know? Maybe I do it like I really ask. Is there a way to know? Maybe we can look at the build information and see how all this image was created.
Okay, and
so let's go to the manifest here.
Yeah.
And it will have a build tab right there. Here you go,
okay.
Builds.
Builds, okay, I see it.
And look, we have some information right here, right?
Let me zoom out a little bit.
Okay, perfect.
So it was built from the CI server.
We can. First of all, we can navigate to the CI server directly,
okay,
right?
Let me open that up. Okay, so build 50, that's from Jenkins. Okay, the build was successful.
Well, that doesn't mean anything. For many, many years, successful build doesn't mean anything.
It's true, because I didn't run any tests. Okay, yeah.
And I know who did -- skip tests as well. I won't name him, but he sits right there. But at least we have the revision in Git. Should we look at the sources, or will it be too early?
Yeah, where is the?
Let's look more into. Let's see more information on Artifactory. Yeah. So let's go to Artifactory again and see what else we have to the build. So we can drill down to the build.
Okay.
To the 50. You're right.
Okay. Yeah.
And see more information here. Okay. So here we know where it built. Well, we've already been in Jenkins. Here are published modules. What we see here. Okay, that makes sense. We have 4 Java modules and 3 Docker images.
Wow.
So we know which module we look at?
Yeah, it was
the UI, right? So let's go into the UI. Okay. Here we see the jar file. Okay, look at that. We have the name, we have the path, and we can navigate to it, and maybe it's something there. You know what? How about environment variables? Are you sure you compiled it with the right version of Java?
Yeah, it should be Java 1.8.
1.8, let's check that. Okay. So let's go to the environment and go to the here and filter by Java.
Oh, there we go. Java Oracle 8, yeah, I see all these things.
Yeah, they look good. It's the right version.
Yeah, looks okay.
Well, so definitely, maybe it's not there. You know what? Let's try to compare it with previous build.
Okay.
So let's go to diff.
Okay, where is the, oh, there we go, diff, this thing right here.
And let's try to compare this one with the previous one, which was 49. Before 50, that makes sense.
I wonder who built 49.
Okay, so we have a bunch of, okay, but obviously the artifacts have changed. We submitted new images and new files, but maybe some dependencies changed. Unchanged, everything is unchanged.
Wow.
We can group it. Those are the new ones, but they are internal, so we're all good.
Okay.
I don't see anything suspicious here.
So at least we're able to figure out that this image is actually the thing that I was supposed to deploy for this demo.
Right, so we know that the image was built, obviously, apparently correctly. There is nothing wrong with the image itself. The jars inside look like they were built correctly as well. The environment variables are fine.
Okay.
We don't see any difference between this build and the previous one, which worked. So I guess we will have to dig into production.
Yeah, but this is still not working. Now, how do we actually do that? So once you have figured out that you actually have the right versions, again, never use latest in production. But if you do, at least you know how to figure this out. But once you figure out that you have run the right application in production, and it's the same as staging, then Kubernetes actually has a lot of really good constructs. For example, we can go ahead and get all of the running instances of my UI, and this log was probably propagated to one of these instances. It was generated from one of these instances. So I can go ahead and use the Kubernetes command line code logs. I can tell one of these instances. Now, Baruch.
Yes.
We got 2 instances running here.
Right.
What are the chances of me finding the logs?
50%.
Which one would you want to see?
Doesn't matter. It's 50%.
Now, wait a second, though, because we're running microservices. It's very, very easy for me to say, scale my deployment, my hello world service. Yeah, and I can say replica is equal to 10.
And your chances just get down to 10%.
Yeah,
yes,
thanks. Yeah, that's no fun, isn't it? But you know, we can still take a look at it, right? So I can say, let me see if this is this one. And I can say, let me tail the logs.
Oh, there is an exception right there.
Oh, pretty lucky. We're pretty lucky.
10%.
Yeah, we should go buy some lottery. Now, if I scroll up, wait a second, let me see. Oh, this is a very, very long log.
It's a Tomcat exception.
Oh my God, what is this log?
Otherwise, no one will believe it's a live failure of a live demo.
What is this thing? I cannot really read this, but if I do find the exception somewhere.
No, you won't.
Oh, there we go. I found it. Oh. Wow, it's a lot of.
Well, it's 404 null. Any better explanation than that? Now we know exactly what went wrong, don't we?
No, I don't know, but whoever wrote this app, I don't know who that is, obviously didn't do a good job on logging.
Not Mark.
But let's see. What we can do, though, is that I wonder if this is happening to instances across this entire deployment. You have 10 instances running right now. Maybe it's on some instances, maybe it's not. Right? And if you think about some of the issues you may have troubleshot before, maybe it was just a bad instance. So how can we figure that out? For that, you actually need a way for you to query the logs, right? You need to potentially aggregate the log together. And it's pretty easy to do in Kubernetes. You can install AlkStack, so you can have Elasticsearch, Logstash, and Kibana, and you can go in and do a search. Now, of course, if you're running on Google Cloud, I can just go ahead and I can find my logging stuff. So I can say, let me see all of the logs that's actually there. I can potentially drill down into my cluster. I can see the apps that I want to search, and then let me just search for exception, right? So here, in this aggregated view, I can see.
No exceptions at all. Like,
yeah. I got plenty of exception here, but that doesn't really help me. I mean, it's good. I can see what's going on, but what I can also do is I can actually export this into BigQuery. Now, I don't know if anyone here heard about BigQuery before, but this is internally, this is known as Dremel. And that is a way for us to query a lot of data. Terabytes, petabytes of data, we can query this in seconds, right? So,
rumor has it that this is how you search in Google.
Yeah. Yeah, that's how we search all the details when we need to troubleshoot something.
Yep.
Yeah. But
what do you do when you need to search the search?
I don't know. Yeah. With Artifactory?
Use big.
Yes, big. Yeah, so let's see. Let me see if I can do this, and let me go to BigQuery. So what I want to figure out is if this is just a bad instance. Maybe it's just a bad instance, right? Which is unlucky. 50% chance, right?
No, it was 10 by now.
It's 10% chance now. So let me go to BigQuery. OK, so I have the logs already exported. And let me see what I can do from there. So I'm going to go into that interface with any proper internet in this conference.
Oh, yes.
Yeah, I can get in. And I got a query here already pre-made. So this query is pretty cool. Because I have all the log entries forwarded to BigQuery, I can actually issue like a SQL query. So, but the point here is that I want to see if this exception is only happening on certain instances of the app or not. So I can see a distribution. I can see whether it happened on today mostly or yesterday. And I can query it. And in this case, maybe, oh, let me scroll down. Maybe it occurs more on this one instance.
It's 25 and everything else is like 3 exceptions. It really doesn't count.
Yeah.
It's only 3.
Yeah.
25, it's serious.
Yeah, so possibly I can go in and if this thing is still running for the whatever, I suppose one of these instances is bad. What we can do? Well, what do you do with a bad instance?
Oh, you kill it.
What? What? You just kill it?
It's bad.
Yeah, sure, you can probably kill it, and people will be happy for a moment. But the thing is that if you kill this instance, the issue may come back in a couple of days later, and you have the same issue again. In fact, I have seen a customer in the past, they actually kill all of their instances every day. Every evening, they kill their instance just because if they keep it running, it's not going to work the second day.
How do you fight a wait a second. This is how you do it.
Yeah.
This is how you fight a memory leak.
No. So what we want to do is to potentially keep the instance running, and so you can troubleshoot it.
All right. So let's do that instead.
So in Kubernetes, what's really, really cool is that every one of these instances is associated with a label. So if I say get pods, I can see the labels as associated with all of these instances. I can, for example, every one of them has a name called a key called app, and they have different values for it. So for example, in Hello World UI, I have the UI as the app key. Oh, sorry, the app key value pair. And then I got this extra thing which is called serving. Okay. Now the beauty of it is that in Kubernetes, these labels can be used for a search. So I can say, find me all of the instances that's running where I say the app label is equal to Hello World UI, and serving is equal to true, right? I can query this. It's like a SQL query.
So this serving actually means that you can make it unserving. You can take it out of the service and isolate it, but keep it running so we can actually troubleshoot it.
That's right. And the way that this works is because that in Kubernetes, we have a first-class citizen called a service. And what that means is it's going to create a load balancer for you automatically. And this load balancer will be able to route traffic to the instances based on the label. So in this load balancer, it's only going to route traffic to the instances with the app is equal to Hello World UI, and serving is equal to true.
Which means that if we just change the label of serving to false, we actually take it out of the pool for the load balancer, isolating it, and can still play with it while it's alive without affecting the customers.
That's pretty much right, yeah.
I would say that's better than killing.
Yeah, if you really
and I don't say that a lot.
Yeah. There's no killing in this session, just so you know. Yeah, but if you do want to get rid of the instance, if you just can't wait, you can do the delete pod.
We decided we have a better way.
Yeah, we decided we have a better way. So what we can do is we can use the Kubernetes command line. We can say, I'm going to update the labels for the pod. And let's say this one's bad, CK07B.
That's the one with the 25?
Potentially, yeah, but this is a little old.
4D8. Do we have the? We don't.
No, that one was killed.
He promised no killing, and you can trust this guy.
But let's suppose that this is the bad instance. What you can say is, I can overwrite the label. I can say serving is false. Let me just do that. And now if I go get pod again, and I'm just going to use this other one. There we go. And if I just want to see app and serving, now this is the magic, right? And if I scroll up a little bit, we got too many of these instances. But you can see that Hello World UI, we took one of them out of service. So serving is now false. So now if I make another request through the load balancer, it will not hit this instance anymore.
It will never go there, but we still can access it and troubleshoot it.
Yeah, absolutely.
Let's do that.
Yeah, and if you haven't noticed also, if you count the number of these instances, we have 11. Even though I took one out of the service, because in Kubernetes, we scaled this to 10, and notice one was gone. Now we only have 9 that's serving. It's actually going to restart another one to take over the instance that you just took out of service.
That's pretty cool.
That is pretty cool. So how do we actually access this? So now I can say this is the instance I took out of service. We can do a few things. We can do an exec ti, so we can go straight into this container.
All right.
Yeah, without SSH or anything, I can go straight in. I can say what is actually running here. I can debug if I have log files, whatever I can see inside. But what's even more interesting is that I can actually open a pull forward thing. So I can say pull forward into this pod, and I'm going to bind my local, say 8000 port, to the remote port on this instance on 8080. Now, what this actually have done is it opened a secure tunnel from my local laptop to whichever server that's running this instance and go straight into that container.
So you bypassed the public IP and the load balancer, so you can directly access this misbehaving container and troubleshoot it.
Yeah, so let's see here. If I refresh here, that's obviously not working. And we think this is the bad instance. Let's go check it out. And, oh.
And this one is not the bad instance.
Shoot.
1 in 10.
What? But, OK.
OK, so our failing demo is a working demo. It should have failed.
No, but that's the whole point. You don't know why sometimes things work and things don't work, right? In this case, we have a theory. We had a theory that maybe this is just a bad instance.
And it's not.
And to test it, it wasn't the case. So what can we do? It looks like it's working fine.
It's working fine.
All right, let me put it back to the survey. So I'm going to do the label again. I'm going to put serving is equal to true.
OK, now you should explain me the rationale of doing that. I would suggest the killing it.
Yeah.
That's because we already have 10 working instances.
Yeah.
We're going to add 11th one now.
Yeah. So now the 11th one goes back. Now you can choose what you want to do. You could have killed it. But we said no killing in this session.
All right. So now we have 11.
Now we have 11, but Kubernetes says, we said we only want 10. So what Kubernetes will do behind the scenes is that it's going to see the 11 instances, it's going to pick one of them, and I'm going to not say the word, and it's going to remove it. Yeah.
Told you. So you actually killed it, but not with your hands. Now it's Kubernetes' fault, not yours.
No.
Nicely played.
Yeah, but however, Kubernetes will go through a certain rules to decide which instance to remove. It's going to remove the one that has the least running time, or it's going to remove the one that's actually not serving, it's not ready, so you don't impact the application as much, right?
So instead of killing the one that we created a very long time ago, mature, had his life, saw things in life, he will going to kill an infant that it was just created.
Not an infant, but it was running for 3 minutes. All right.
Infant.
No killing done in this talk, just so you know. All right, so well, that wasn't so bad. So now we are able to, first of all, figure out this is running the right app. We can tail the logs. We can search the log in aggregate. We can kind of have a few theories on why things don't work, right? And then we can investigate. But sometimes it's just not enough. Now, that log message, I don't know where that comes from, but it's 404. No, I don't know. It wasn't very useful, was it?
It wasn't useful at all.
How many people here have seen log messages just like, yeah, I don't know what's happening?
Null pointer exception, null. That's my favorite.
Now, what do you do? What do you do when you see that? Baruch, what do you do?
So I'll tell you what. I open the source code. I add proper logging.
Okay.
And then I commit it. It goes to Jenkins. It builds. It packs it up in the container. It builds the container. And then it goes to production. And then it works. And I have better logging in just half an hour of time. And I hope that that exception will happen again. And all that work won't be for nothing. That's what I do.
But wait, only 30 minutes? That's not bad. That's not bad. I think for most of the other people I talk to, right, they actually have to spend time. Well, first of all, you need to modify the right version of the code.
Right.
Right?
But that we know.
Right?
That we know.
Yeah, and that we know. So you have to check that out.
Exactly.
Right? And then you add whatever logging. What if that wasn't enough?
All over again?
All over again. There you go. Now, I don't know what people, how long it takes for people to do that here, but I'll show you something pretty cool.
Let's do that.
So let's see here. So I got the messages here, right? I have all the logs, but it's not enough. It's definitely not enough. I got so many exceptions here. Yeah, I wrote the code. I'm sorry. But what we can actually do is that at Google, we have something that we actually use internally. It's actually a debugging agent that we can attach to a running application. Yeah, and this works for Java and Python and Go. Because we're using Java, I'm going to show you what we can actually do. What that means is that in that Docker file, we actually added the agent already that's running attached with the application. I'm going to close a few things here. And what I can do is I can go to debug. It's a little small here to see. Okay, debug. Where's my internet? There we go. Now check this out. Because in the build, we actually checked in the Git property files as well. I'm using Maven. I'm using the Git ID commit plugin. So in my package, I have a Git.properties file. In that file, it actually pointed to Baruch. That's your code.
Mark.
So it's pointing to Baruch's code. And it actually figures out exactly which snapshot or which commit ID that's running in production right now. Okay?
We can blame it on other people. It's a fork of Spring Boot examples.
Yeah.
Let's blame it on Pivotal.
There you go. Yeah, it's definitely not my fault. All right, so because of this, I can actually go and debug this code. And you can actually browse the source code. It got it from GitHub. And I can browse through this code, and I can find, potentially, where I need to add a log. So if I scroll down a little bit, I would be saying, wouldn't it be kind of nice if I know, for example, what the name was when it was being passed through?
Right.
So what I can do is I can add a log point. And here I can actually just say, let me go ahead and print out the name. The greeting is greeting. So I can actually reference them with a variable. So I can add a log point here. Good. And then let me print out the name here as well.
Right.
The name is name. OK? I can add it as well. And then maybe I need to do some troubleshooting here. Like the code was here, right? What do? We usually say hello, right? It's just say hello,
yes.
so you know, like hello 1 and hello 2. So I'm going to say hello 2. And maybe it came through here, so I'm going to add hello 1. OK? So now I got a bunch of log messages. Now, without deploying the code, this is actually applied to all of the running instances. All of those instances that I have so far will be able to generate this log. So if I go back to this thing, I do the refresh, I don't see anything. But if I go back to my logging console, where's my logging? There we go. Because I want to see the aggregated logs, if I do the play, hopefully I'll be able to figure out something here. Okay? So if I zoom in here, oh, interesting. See, I can see hello 1 was triggered. So I know I was at that line of code. And I can see the name identifier, the name was not found. OK, fine, I was a name. Oh, the name is empty.
This is so cool.
It's not cool.
No, that I'm not playing. It is cool.
It is cool, right?
Yes.
So now, without having to redeploy your code, you can just add more logs. Yeah. And by the way, this works not just on Google Cloud. If you're running this on-prem, you're running this on another cloud, you can actually connect to this service.
Are there any other clouds? Nah.
No, I think this one's best.
Nah,
yeah. But that's not cool enough. We can do even more.
Wow.
Yeah. So anybody here ever wanted to, say, troubleshoot or debug your application live? Now, the way that we do it locally is we run a debugger. Okay? So you can do that. So if you isolate your instance, what you can do is you can open a pull forwarder, right? And you can connect to a remote debugger. But what is the problem with that? When you put in a breakpoint is called a breakpoint for a reason. It stops the code.
It does.
So as the traffic is coming through, your users are not gonna get any response until you said continue.
You just connected a debugger to the live code, put a breakpoint, and you stop the world.
You stop the world. So what we actually do is that with the same debugger, if we go back to the UI here, I can actually add what we call a snapshot. Now, that is different from a breakpoint because this captures the snapshot of the state of your application with all of the stacks as the application is running. Okay?
Without actually stopping.
Without actually
stopping.
It
will give you the same look and feel that you have all the information from this frame, but the application will go on.
Exactly. So for example, here, this is the service that's actually making the call. I can actually add a snapshot here. So I'm going to make sure I have a snapshot. OK, is that right? There we go, snapshot. I'm going to delete that one. And here we go. So what this is saying is I want to capture the frame as the code is flowing through this line of code.
And it's waiting for a snapshot to hit.
It's waiting for a snapshot.
Yeah,
so I can go ahead and refresh.
And hit it.
Yeah. And if I go back, it says it captured a snapshot.
Let's look at it. We have 10 minutes to fix this demo.
Yeah. So let's see here. So we can see that the name is obviously empty.
That's what we got from the logging as well.
Right. And I can see the code stack, and we can kind of see exactly which things that it went through.
Yep.
Now, why is the name empty? Did you run this demo earlier? Did you use my computer?
I never would do that. Never, ever I would touch your computer with a stick. Yeah. No.
Why is the name empty? So if I actually examine the code, I can actually see this.
It's Java. No one here knows Java.
No one? No, I love Java.
Who knows Java?
Everybody knows Java. How many people use Spring and Spring Boot? Anyone? Yeah, quite a few. So you probably know what this annotation is. What does that actually do?
Session attributes means that name comes from session.
The name comes from session. So would it be possible where maybe this line of code, maybe that's where it went wrong, because name has been empty, and we know the code went through hello 1, and it definitely tried to use this log point because it said the name was not found, and it never got this far.
No, we didn't.
And we saw the stat trace, it probably came from here, right?
That makes sense.
So
it was for not found, name not found. Now it suddenly makes sense.
Yeah, so this is a user error.
It is.
Somebody putting empty name.
Yeah. Shame on them.
Shame on them. Yeah, so I guess what do we do? Well, we can clear the session. We can fix the code.
We need to clean the session and then just run it again.
All right, so how do we do that? So what I can do is I can, of course, go to my browser and clear the session. But of course, I wanna fix this code, so I can do that separately. But the fastest way is to clean the session. I'm gonna delete this pod called Redis. I'm gonna do it.
He's killing them again. Just saying.
Yeah, just saying. So now I just deleted everything that's in the session. So I cleaned the session. Don't do that in production, just saying.
Don't do any of that in production, by the way, except of the good parts.
Yeah, exactly. But it came back really quickly. So there's my Redis pod. So it's up and running again. And hopefully, if I go do a refresh.
Oh! We fixed it!
Yay! Not the right way, but we fixed it regardless. So just to make sure it works, I'm gonna say I'm gonna be my manager, Greg. His name is Greg.
Good job, Ray. This is what. Yeah.
And there you go. So yeah, not bad, not bad. So hopefully you see some of the really, really cool tips and tricks, right? Isolating your traffic. You can take your running instance out of the serving path and you can debug it. You can open the port directly to the instance. You can aggregate the logs and do some searches. And if you got the right tooling, you can actually query and analyze the log to figure out if it's just one instance or everyone or certain hours of the day. And finally, we have tools that you can actually use to debug live application and adding additional log messages. We actually use the debugger at Google as well. And this debugger is actually open source. It's just that you connect to the cloud service for you to connect everything together.
Right? That was pretty cool.
Yeah, all right.
We have a couple of minutes for questions.
Yeah.
Yeah, so why all the killing would be my first question, but you go ahead.
That's a great question. So the question was, can we automatically capture the exception or take a snapshot?
And I would say not with your amount of exceptions because there is no computing power in the world to that.
I got just too many of them. Yeah. But what we can do is that we can actually capture all the exceptions that you generate, and we can make a report for you. So there's actually a really cool thing if you do this properly, right? We can actually have this thing called error reporting. So what this actually does is capture all of the exceptions, and we can actually tell you what are the most common exceptions, and you can act on it. Now, in the debugger, though, it doesn't generate this frame automatically, but what it can actually do is we can set conditionals. So for both the logs and the snapshot, what we can do is we can say, let me add a snapshot, but here's the condition. I can say if the name is empty or something like that. So if you actually have like a request ID, a trace ID, or maybe a session ID, you can potentially say, OK, I need to see what's going on for this particular request. And you don't have to apply this log to everybody, but now you can just apply it to specific conditions.
But I think that's a good feature request. Snapshot on exception. I like it.
That would be pretty cool.
Makes a lot of sense.
Yeah.
What Overops is doing, for instance, that they can't capture everything, but let's say for the top 5,000 exceptions, they just keep traces for some of them.
Yeah.
They are Google. They can capture everything.
So we do keep the traces for those, not the frame, not the stack, but the stack trace itself we can keep. Yeah, and that's going to be stored in the error reporting, and you can see all the common errors. Yeah, so it's slightly different. Yeah, cool.
So what do I need to use this myself?
What do you need to use this yourself? Well, very good question. You can, well, first of all, we have the plugin, depending on the framework you're using or the language. Is it Java or something? C++, yeah. Yeah, I don't think we have a C++ debugger that connects live, but a couple of things you need to do. First of all, you need to download the debugging agent. You got to put this into your application. In Java, you just download it from a curl, and then you can put it into the Java command line when you start up. But the second thing is you gotta get an account on Google Cloud. But this service is actually free, so you can just create an account and then say, I need to debug against, forward all of the messages to this one project, then you're done. Right?
And for the image part, what do they need to do?
For the image part, of course, if you want all these niceties that you saw, you put them in Artifactory.
Here we go. That you already have.
Yeah. Any other questions? Yes? Can you do this in IDE? And you absolutely can. And I don't have that. Yes, you can. And we have plugin for IntelliJ, for example. So from here, if I have the right project open, in the IDE, I can attach the debugger to the remote instance, and then I can do all the snapshot directly from here.
It's exactly like a remote debugger attached to whatever system runs.
Yeah, exactly. Now, what this actually does is that you have your source code local, so you don't have to upload the source code to GitHub or anything, and you can just in the IDE you can say which line of code you want to debug. And these stack traces, these frame, will be propagated to your IDE. What's even better, this is actually what happens to a lot of people. Production code is maybe like 2-3 iterations behind the scenes. You're already working on something new. When you try to debug something in production in the IDE, we will switch the tag or switch the revision of the code.
You need to check out, you need to find what exactly was wrong. Although you do see the tag right here in Jenkins, right? That we have.
Yeah.
Where is our Jenkins guy?
Oh, I think I closed it, yeah. But there we go.
Yeah, so right, just, no, in the general info and here, right? So you do have the revision right there. Yeah. Right, so you can go and just check out it in your IDE, and it might be more convenient to examine it in IDE. But the benefit of doing it live is that you know for sure that you're debugging the code that actually runs.
Right.
That's the difference.
Yeah, but if you have that git.property file, it will have this revision IDE in there, and the IDE will actually switch your code to the revision that's actually running in production, and then that's where you can add all of these log points and whatever. And then, when you're done, it will switch you back to your previous master, and then you can continue to work on your code. Mm-hmm. When a snapshot comes in, we'll switch you back to the code that's running on production. So we do this automatically switching for you as well.
Oh, this is cool.
Yeah. So, any other questions?
OK, let's wrap it up. So guys, first of all, there are feedbacks on your tables, and don't forget to fill them. And also, as we are the last session of swampUP, that's our opportunity to thank you for coming to swampUP. And I hope you had a great time. As I mentioned, if you liked it, it's all thanks to the speakers. If you don't, it's JFrog fault, but you do liked it, I know. And I hope to see you all next year. So until next year, thank you very much, and bye-bye.
Thank you. Thanks, Baruch.
That was good.